In this video, we will learn how to multiply square roots. So let's begin by reminding ourselves what we already know to be true about square roots. So we know that a square root is essentially saying what number times itself 2 times is going to give me 64, or what number squared gives me 64. So when we're evaluating a square root, we're trying to figure out what number to the power of 2 gives us the number underneath the root. And if we use our calculator here and we plug this in, we will find that x is equal to 8, or just that the square root of 64 is the value of 8, because 8 times 8, or 8 to the power of 2, is 64. Now some of you may have known that off the top of your head, which is great because that's a pretty common squared number, but some of you may not, and that's fine. When you use your calculator, typically, if you're looking for this button, you'll typically have to push the second button first, so there's a little button that says second, and what that second button does is it says that it's going to do whatever function is not actually on the button, but right above it in a different color. And typically the square root button is also on the button that goes along with the squared. So you should be able to find that there. If you need help doing or evaluating your square roots, please let me know when you see me in class. This next one here is the square root of 225. Now this isn't as commonly known, so you might not know this one. So if you push the second button, and then push the button that's right below this square root symbol, you'll be able to open up the square root function. And then if you type in 225 and close it off with a parenthesis, and then press enter, you'll find that the square root of 225 is 15. And that's because 15 times 15 gives us 225. And then lastly, if we use our calculator for this final one, the square root of 57,600 is 240, which tells us that 240 times 240 will give us 57,600. So that's what we in general know about the radicals or roots currently. So now let's look at the parts of a square root in a little bit more detail. The first thing I'd like you to note is that while the symbol is something we've called a square root so far, it actually has another name in math called the radical sign. So if you hear me say the word radical sign, I'm simply referring to that square root symbol here. Then the second thing you need to know is that this part with the square root, this number underneath the square root is called the radicand. So not a popularly used word, but the radicand is what's actually underneath that square root symbol. Then from there, we have what's called the coefficient, and we've talked about coefficients before. Coefficients are typically referred to as the number in front of a variable value, but here our coefficient is also referred to as the number in front of a square root. And then from here, this entire thing together, so the coefficient with the radical sign plus the radicand number underneath the radical sign, is called a radical. So you'll notice that this word radical seems to appear multiple times, and you should at this point hopefully be noticing that radical is talking about anything related to square roots. Now the last thing we want to talk through is how this is typically pronounced. And this whole radical up here is typically pronounced as 2 times, so notice that multiplication symbol in between. So 2 times the square root of 7. That's how we would typically probably say it right now. But the shorter way of saying that is just 2 radical 7, which is really saying 2 is the coefficient, the radical sign goes next, and then the 7 is the radicand underneath the radical. So in class, we filled out this table here. And we started off by calculating these multiplication problems. Now as you enter these into your calculator, please be careful. You'll have to do the square root symbol. Most of the time it opens up a parenthesis underneath the radical. You'll then need to do your 3, and then you'll have to close off that parenthesis to make sure that you close off the radical, and then do your multiplication symbol. Open up the square root, type 32 and close. If you're not careful with these parentheses, you might actually get the incorrect answer. So just be careful as you type, but take a few minutes, fill in each part. So go through the multiplication problems first, going slow, then evaluate these values here and these values here. So take a few minutes, work through those, and then we'll continue on with the video. So your fill-in chart should look something like what you see on the screen. And what you're hopefully noticing is that these first two have identical values. So what that's telling us is that the square root of 3 times the square root of 32 is the same thing as the square root of 96. So we can actually take these multiplication problems and condense them down into a single square root. And if we look closely, so here we have the square root of 17 times the square root of 2 is the same thing as the square root of 34. Square root of 50 times square root of 3 is the same thing as the square root of 150. Square root of 5 times square root of 2 times square root of 3 is the same thing as the square root of 30. And then square root of 10 times square root of 2 times square root of 5 is the same thing as the square root of 100. And what I'm noticing here is that the numbers underneath the square root, if we multiply the numbers underneath the square root together, we get the number underneath the square root here in the second column. So what that's telling me is that if I see a multiplication problem that contains square roots, I can simply multiply the two numbers underneath the square roots and rewrite them as one simple square root. So I can now write what I saw on the previous page in general. So this says the square root of a product equals the product of the square roots of the factors. So while that sounds like a lot of math gobbledygook, what that's actually saying is that if we see a math problem like this, if we see a square root times another square root, what we can do is we can take those numbers underneath the square root, multiply them together, and rewrite them as one root. So if we put this into actual numbers, what this is saying is that if we have the square root of, let's say, 10 times the square root of 2, we can really rewrite that as the square root of 10 times 2. So notice both numbers are underneath one square root being multiplied, which is really the square root of 20. So now what we're going to do is we're going to use this property for multiplying square roots to actually rewrite square roots that are being multiplied, and then hopefully we'll be able to evaluate them accurately. So on the screen here, you'll notice that we have two multiplication problems. And essentially what we're able to do is, since we have a square root times another square root, we can rewrite this as one square root with the two numbers underneath being multiplied underneath that one single square root. So the square root of 6 times the square root of 6 really represents the square root of 6 times 6, which is really the square root of 36. And then we're noticing, well, hey, that's a number that I know how to square root. It square roots really nicely. So the square root of 36 is 6. So as a result of understanding this product property of radicals, we're able to rewrite them, and this first one we were actually able to evaluate. Now if we look at this second one, if we go through that same process, we can turn this into one square root with 3 times 27 underneath. And then from here, this becomes the square root of 3 times 27, which is 81, which I then notice, well, hey, that's a number that I can easily square root because the square root of 81 is 9. So again, that product property of radicals allowed us to actually evaluate these square roots further. Now the last thing we need to talk about here are what happens when there are numbers both inside and outside the square root. So notice here we have 2 and 3 on the outside, and the square root of 5 and the square root of 20 on the inside. Now numbers that are underneath the square root are different than numbers outside. So what we're going to do here is we're going to deal with the numbers inside and the numbers outside separately to start. So what we can start off doing is we can start off by multiplying the numbers that are outside the square root. And we're going to leave them outside the square root. So here I notice I have 2 times 3. Well, 2 times 3 leaves me with 6. And then the second thing I'm going to do is I'm actually going to multiply the numbers inside the square root together, and I'm going to leave them underneath the square root. So here I notice that I have 5 and 20. So the square root of 5 times the square root of 20 can really be rewritten as the square root of 5 times 20, which can then really be rewritten as the square root of 5 times 20 is 100. And then what I notice is that the square root of 100 is 10. So what I'm going to do is in place of the square root of 100, I'm going to write just 10 because that's something that it is equivalent to. So here this is now 6 times just 10, which is 60. Now if I look at that second example over there, I'm going to go through that same process. Multiply the numbers on the outside of the square root. So I have 5 times negative 4, which is negative 20. I then have numbers underneath the square root of 7 and 3. So I multiply 7 times 3, which I then know I can rewrite as the square root of 21. And I know if I try to use my calculator, the square root of 21 is not a number that I can easily square root. It's a crazy decimal. So I'm actually just going to leave my answer as is. So let's practice 4 more very quickly. So remember, we always start off, we're going to multiply the numbers on the outside, and then second, we're going to multiply the numbers on the inside. So I notice here in this first example, I have no numbers on the outside, so it's really the square root of 8 times the square root of 8, which turns into the square root of 8 times 8, which is the square root of 64, which is 8. Then if I look at that second one, what I notice is I have numbers on the outside and inside. So I start by multiplying the numbers on the outside, which give me 8 times 2 is 16. I then have numbers on the inside, so that turns into the square root of 8 times 2. So then I have 16 times the square root of 16. Now what I notice here is that 16 right here is outside of the square root, so I'm going to leave it as is. But this one, I know that the square root of 16 is 4. So I'm going to change the square root of 16 to something it's equivalent to, which is 4. So now I have 16 times 4, which is 64. Then if I look at my next example here, I notice I have numbers on the outside of 5 and negative 2. So 5 times negative 2 becomes negative 10. And then have numbers on the inside of 2 and 3. So it's the square root of 2 times 3, which is really negative 10 times the square root of 6. And since the square root of 6 isn't something that evaluates really simply, I'm just going to leave it as is. Now this last one here, I note that I have numbers on the inside and numbers on the outside. So numbers outside, I have negative 7 times negative 3, which is 21. Numbers on the inside, I have 5 and 6, so that's the square root of 5 times 6, which is really 21 times the square root of 30. And since 30 isn't a number I can easily square root, I'm currently just going to leave it as is.